The scope of Earth science. So, Earth science is really the study of the Earth and the universe around it. So, that is the scope of Earth science. It's the study of anything involving the Earth, the solar system, galaxies, etc. From maps and navigation to weather reports, Earth science is a part of your daily life. So, if you ever ask Google to give you directions somewhere, you're using Earth science, you're using GPS. If you ever watch the weather or check your phone's weather report to see if it's going to rain, you're using Earth science techniques and results. This began thousands of years ago. Early discoveries were limited to observations and phenomena that could be seen with the unaided eye, although we do believe some early structures were built as timekeepers or ways to observe different phenomena in the sky, but they're still it was the unaided eye. There weren't telescopes or anything like that. Science also assumes, any science really assumes, that the causes of natural events or phenomena can be discovered through observation and experiments or experimentation. Some notable early discoveries. So the Chinese kept records of earthquakes around 780 BC. The Greeks cataloged rocks and minerals in around 200 BC. The Maya built observatories to track the movements of the sun, the moon, and planets. The Babylonians charted the positions of planets and stars nearly 4,000 years ago. So Earth science is a very old field of study. And a lot of this timekeeping and tracking planets and stuff was really, meant for timekeeping. So they know when the seasons were changing, they know when to plant crops, and they know when the rainy season was coming, things like that. So they could plan ahead. Branches of Earth science. Earth science is a vast field of study. It's often multidisciplinary, which means it incorporates a variety of different topics of study. There are 5 major branches. You have astronomy, you have meteorology, you have geology, you have oceanography, and you have environmental science. We'll talk about each one of those individually now. So astronomy is the study of objects beyond Earth's atmosphere, including the entire universe. It could be the solar system, it could be our moon, moons around other planets, exoplanets, etc. Exoplanets are planets around other stars. One of the oldest branches of Earth science is astronomy. Early astronomers merely described the locations of objects in relation to each other. Modern astronomers study the movement, composition, and structure of stars, moons, planets, and galaxies, and the universe, really using fairly sophisticated equipment, including different space-based telescopes, land-based telescopes, different sensors, etc. So meteorology. Meteorology is the study of the forces and processes that cause the atmosphere to change and produce weather. Meteorologists study atmospheric conditions using sophisticated equipment such as satellites and radar, and simpler technology like thermometers and windsocks. Meteorologists also try to forecast the weather, so that they try to predict, is it going to rain this afternoon, is it going to be sunny tomorrow, is it going to snow, etc. Some meteorologists study the climate. These are climatologists. The difference really is weather is what it's doing outside at the moment. So if it's raining or sunny or whatever. Climate is really sort of long-term trends in the weather, long-term weather patterns. Geology is the study of the materials that make up Earth, the processes that form and change those materials, and the history of the planet and its life forms since its origin. Specialized fields in geology include earthquakes, so studying earthquakes, those are seismologists. Studying volcanoes, those are volcanologists. Studying glaciers and glacial movements, those are glaciologists. And then studying Earth's history through the study of rocks and fossils, those are paleontologists. Oceanography. So oceanography is the study of Earth's oceans, which cover nearly 3/4 of the planet. Oceanographers may study creatures that inhabit saltwater, that'd be marine biology, chemical and physical properties of ocean water, tides, waves, and currents, structure of the ocean floor, Some that gets into like what they call physical oceanography, or I guess chemical oceanography. But this often involves diving and submersibles to study in the oceans. Also, involves a lot of time on boats if you're studying anything that's very far from shore. And then environmental science, which is sort of the baby of the group. Ecology, got to start there. Ecology is the study of interactions of organisms with their surroundings. That is a field in biology. Okay, so ecology is really the study of interactions between organisms and their surroundings. So what do certain animals eat? What do certain plants require to grow? That sort of thing. Environmental science is really ecology plus the effects that humans have on those natural systems. So definition in the book doesn't quite do that. Actually, the definition in the book really has environmental science defined as ecology, but I like to make that distinction that environmental science really looks at the effects that humans have on those natural systems. And so environmental science is really a very broad kind of science. But environmental scientists study both positive and negative impacts on the environment. Example topics may include the use of natural resources, effects of pollution, alternative energy sources, and the impact of humans on, say, the atmosphere or water resources, that sort of thing. But if you look over here, you get this idea of a large number of things that are in environmental science. So biology, you have to know something about biology because ecology is really in this. Ecology is part of this. Chemistry, physics, geology, geography, so landforms and that sort of thing. Anthropology, which is the study of humans and human civilizations in general. Demography, which is the study of human populations. Economics, which gets into finance and business and that sort of thing. Political science, so the politics of all this and the laws and that sort of thing. There are environmental regulations and that sort of thing. Philosophy and ethics. So a lot of things go into environmental science. And just some subspecialties here. We'll just kind of compare a few of these. So subspecialties. So for astronomy, you have astrophysics, which is really the physics of the universe, including the physical properties of objects found in space. You got planetary science, which studies the planets of the solar system and the processes that form them, not just our solar system, but any solar system, which we know there's a bunch of others out there now. Meteorology, so you can look at climatology, which is the patterns of weather over long periods of time. Atmospheric chemistry, so the chemistry of Earth's atmosphere and the atmospheres of other planets. Geology, which you get into paleontology, which is studying the remains of organisms that once lived on Earth in ancient environments. So you're talking about like dinosaur fossils and things like that. Geochemistry, looking at Earth's composition and the processes that change it. Oceanography, you get into physical oceanography, which is studying the physical characteristics of the oceans, such as salinity, waves, currents, etc. Marine geology, which is studying the geologic features of the ocean floor, including plate tectonics of the ocean. And again, marine biology we kind of threw in there with oceanography as well. Environmental science, so environmental soil science, interactions between humans and the soil, such as the impact of farming practices, effects of pollution on soil, plants, groundwater, etc. Environmental chemistry, really looking at chemical alterations to the environment through pollution and natural means. You can also have environmental biology, etc. There's other different branches of environmental science.